A hare and a tortoise compete in a race over a course of 1 kilometer long. The tortoise crossed straight and steadily at its maximum speed of 0.2 meters per second towards the finish line. The hare runs at its maximum speed of 8 meters per second towards the goal for 0.8 kilometers and then stops to tease the tortoise. How close to the goal can the hare let the tortoise approach before resuming the race? Which the tortoise wins in the photo finish. Let's just pretend that they go on a tie. Assume that both animals, when moving, move steadily at their respective maximum speed. Alright, so this is a constant acceleration where the acceleration is 0 meters per second square. And we're talking about a race between the hare and the tortoise. So let's draw this. I encourage you, the first step to solving the physics problem is to forget about the mathematics. Just visualize the physical scenario, what's going on. And then the next is to solve it or conceptualize. And then you know the rest. All right, let's visualize this. So this race is 1 kilometer long. So here you have a rabbit and a turtle, and this is going to be a 1 kilometer race. So what's going to happen is they're going to race. This rabbit is going to travel at a speed of 8 meters per second, and this turtle is going to travel at a speed of 0.2 meters per second. This video is going to be a little longer than usual, by the way. I'm going to try and take my time on this. So I'm not going to make, because the conceptual part is the most important part about these series, and I hope you take that. I mean, if you guys don't want to learn, then get the heck out of this channel. But if you guys are here to learn, then please stay. All right. Anyway, so the rabbit is going to travel at 8 meters per second. Then it's going to stop. And it's going to stop this is not to scale. So this rabbit is going to stop at 0.8 kilometers. And by the time then, this tortoise is going to keep moving. It's going to go bypass the rabbit. And it's going to be a little ahead. Let me take this off. To the point where the rabbit, once he's past a certain point, so let's call this x naught. In fact, let me, I'll keep the variables, I don't really care. X naught, and at that point, that's when the rabbit will start to say, oh shit. And then they both move. The tortoise and the rabbit, we're going to presume that they finish the race at the same time, at the cross finish line. Because the question is asking, stops to tease the tortoise, but how close to the goal can the hare let the tortoise approach before resuming the race, which the tortoise ream. So the conceptual part is very important for these problems. So, because this is not about solving or how to set up the equation, even though it is. This is morely about how do you use the information given to solve this. Is this solvable? Yes, it is. But we're going to be finding this x naught, this x, and I'm going to say that x is going to be 1 kilometer. And x naught is going to be some value of x naught that we don't know about. And the speed of the rabbit, I'm going to call this v of the rabbit, and I'm going to call this the speed of the turtle. The speed of the rabbit is going to be 8.0, what does it say, 00 meters per second. The speed of the turtle is going to be 0.200 meters per second. I'm not sure how good this video is, but so what I want to do first is let's focus more on conceptualizing than solving this problem. If you guys have a hard time solving this, let me give you a scenario. Actually, I'm not even gonna erase that. If you're just given, if you just think about something, think about a runner, right? Your friend or whoever that is. And if you ask that friend and they give you maybe the average speed that that person runs, let's say that person runs at 8 meters per second. Well, and they're competing in a 1 kilometer race, you know, or let's say that the turtle has a specific speed, which is 0.2 meters per second. If you're just given the speed of the turtle and you're given this distance of the race, ignoring the rabbit, how far of x naught does he have to be? See, that's not, you can't just solve it with just the information of the turtle. Because if you're just given the speed, you can't find where the x naught is because you're not getting it in a scenario. But the scenario is this. How close can the rabbit let that turtle x naught approach? So think about what happens. In the beginning, the rabbit goes ahead, stops at 0.8 kilometers, and then the turtle keeps moving and moving to the point where it bypasses the rabbit. And then the question is asking, how close can the rabbit let the turtles be? Well, once it passes it, once it reaches a certain point, which we don't know what that point is, what x naught is, and this is going to be x1 by the way, what we do know is the time it takes for this rabbit to complete the finish line, and that same time interval is the same time interval it takes for the turtle to complete the finish line. So at this point, at this moment in specific time, whatever that time is, which we don't know, and I don't think we really matters, but what we do know is that how far, you know, let's find the time interval it takes for this rabbit to go from this point to this point. So just the delta t. So I don't generally like to view the equation as delta t, but I'm going to make an exception. So I'm going to take how far. So this is going to be a 1,000 kilometer race, right? And this is going to be 800 this is 800 meters. So the time it takes for this velocity, because remember the distance equals the velocity times time. You flip this equation around, then you get the time being the position over the time interval. I'm just going to call it, oh, what the heck did I do? I'm going to call it delta x divided by delta v. Or just v, I guess. However you guys want to view it. I don't really care. So, however you guys want to set up your equation. So I'm going to take this difference here to be 200 meters, which is 0.2 kilometers. The time it takes for this when the rabbit runs at a speed of 8 meters per second. You guys catch that, folks? So the setup here is going to be 200 meters divided by 8 meters per second, or in this case, the time it takes for the rabbit to go from this point to that point is going to be 25 seconds. You guys catch that? So if the rabbit is running at a speed of 8 meters per second, in 25 seconds, it's going to travel 200 meters. That same time interval is going to be the time it takes, whatever that speed of the turtle is, to run at the distance of x1 minus x naught. I'm just going to set it up this way. Whatever this difference is. Do you guys catch that? Do you guys see what I did there? Oh, actually, what am I doing? Yeah, no, actually, this is right. This is right. So let's solve this. So let's put 0.20 meters per second, the velocity and the time, which is 25 seconds. Use your TI-84 calculator. 0.2 times 25, so that's going to be 5 meters. So that's going to be 5 meters. So that's 5 meters right there. Or in this case, x naught being, so x naught is going to be 1,000 meters minus 5 meters, which in this case is going to be 995 meters. So this is 5 meters. This whole thing is 1,000 meters. 1,000 minus 5 would be this x naught. To solve this problem, so this is 25 seconds in between, where the rabbit travels the finish line at that speed that it takes for it when it runs at 8 meters per second, and that's the exact same time it takes for the turtle to run 5 meters at that speed. That's how you solve this problem, folks. They both cross the finish line at the same time, even though the turtle went a little ahead. So a little extra, if the turtle travels a little extra ahead, just a little bit of extra, then the turtle wins. So I hope you guys find this problem very straightforward and easy. I know this might be a confusing problem for a lot of you, especially if you're not used to the conceptual part. But once you got the hang of it, this should be pretty straightforward for you guys. And I hope this helps. And let me know. Anyway, subscribe to the channel if you're new, and help this channel grow.